Hi everyone. In this video, we're going to talk about artificial intelligence in Unreal Engine 5. We're going to be building a guard that will patrol random areas in our map, and in future videos, we'll build on this guard and expand it so that there's support for investigating any noises that the guard hears. By the end of this tutorial, you should have an understanding of behavior trees and blackboards, as well as blackboard tasks. We'll have built a guard that patrols the map, and we'll do this leveraging the nav mesh bounds volume. Before we get started, it's a good idea to be familiar with the Unreal Editor interface and how to navigate the interface. A high-level understanding of the gameplay framework is also helpful, and understanding the basics of blueprints in the event graph will also be useful. If you're not familiar with these topics, that's okay, as I'll be explaining as much of it as I can as we go along. So when we talk about artificial intelligence in Unreal Engine, we're talking about autonomous actors that are not controlled by the player. These are most often called non-playable characters, or NPCs. As developers, we want our NPCs to behave realistically and be believable for our players. Fortunately, Unreal Engine provides some very useful tooling to help us achieve that goal. And while there's lots of useful elements in Unreal Engine's AI toolkit, we're going to focus today on behavior trees and blackboards. In future videos, we'll get into the perception system and more in-depth into the navigation system. There are also additional components, such as the environment query system, and some really exciting new elements that are experimental or beta for now. We won't be talking about any of those today, and we're only going to lightly dabble in the navigation system. Behavior trees and blackboards form the foundation of NPCs within Unreal Engine, so it's a really good place for us to start and have a solid understanding of what they are. So starting with behavior trees, these are the decision makers for our NPCs. They're very simple to set up and they can provide some very complex and very customized behavior using just a few very simple nodes that we'll talk about shortly. Behavior trees make decisions based on input and execute tasks, which are just discrete units of work for our AI. We'll be building a couple of tasks for ourselves today, or at least over the next couple of videos. Blackboards, on the other hand, serve as the memory storage for a given AI. All right, you can think of it as the brain where we're sticking memories and stuff. Blackboards are a collection of key value pairs specifically designed for use with behavior trees. So entities, tasks, other actors, they can all write information to the blackboard using specified keys, and then the behavior tree can read that information and make decisions based on what's available on the blackboard. So we'll look at how to set that up as well today. All right, let's go ahead and get into Unreal Engine and do some initial setup for our project before we come back and look at some of the definitions that we're going to be talking about. So I have created a blank third-person template project. So it is a new project using the third-person template from Unreal Engine, and I've gone ahead and added the starter content to it in case we need any of those resources. I'm going to start by, in the content browser, creating a new actor. And if you don't have access to your content browser, you can open it using the control button and space, or pressing the little control drawer button down here at the bottom. I'm going to go ahead and do a new folder called Blueprints. And inside of that, I'm going to go ahead and create our new actor character, our NPC guard. So I'm going to start with right-clicking and selecting Blueprint class. And then I'm going to go ahead and select character as the base class. Now, an actor is anything that can behave and exist within our game world and have its own agency and behavior. So actors form the foundation of any interactive element within our game world. So I'm going to call this new character class, this guard, BP_guard, where the BP is short for blueprint. If I open this up, I'm greeted with the viewport that has a capsule component, as well as a couple of other components that aren't really visible to us yet. In order to get something kind of rendered there, I'm going to go ahead and just select the character mesh component. And for the skeletal mesh, I'm going to look for SKM Manny. And I'm going to go ahead and just grab that. Now, he doesn't quite position himself correctly, so I'm going to go ahead and just drag him down a little bit on the z-axis so that he's at -80, And then I'm also going to change that rotation to -90 on the z-axis so that he's facing forward. I would also like him to have some animations rather than sitting in this A pose. So for the anim class, I'm going to go ahead and just find ABP Manny for animation blueprint Manny. Now we can see that he's just idling. If we go ahead and position him in our game world, and I'll actually go ahead and just turn him around so that he's facing towards our player, and then we'll hit the end key to snap him to the ground. If we hit play, he just kind of sits there. He's idle, not in the A pose, but he's not doing anything, which is to be expected because we haven't created any kind of behavior for him to exhibit. So in order for us to do that, we need to go ahead and create a controller and a blueprint and a blackboard for him. So let's just take those one at a time. I'm going to start with the AI controller. So I'm going to do a new blueprint class again. And this time I'm going to search for AI controller down here. Now, a controller is part of the gameplay framework, and it acts as the abstraction between the actual entity being controlled and the thing doing the controlling. So normally we think of the controller as the will of the player, right? You have a player controller, and that's where that's what you control and interact with. And then that player controller typically drives the pawn. The same system kind of applies for NPCs. We just have an AI controller instead of a player controller, and then that AI controller can possess and control a pawn. So I'm going to go ahead and just use AI controller as our base class and do AIC underscore guard. I'm going to hit F2 to rename that, AIC underscore guard, where that AIC is short for AI controller. Inside of our guard blueprint, if I search in the if I grab class defaults here, and then I search for controller, you can see that under the pawn subsection, there's the AI controller class. I'm going to go ahead and change that to AIC guard so that we're actually using our specific guard subclass for the controller. I'll go ahead and compile and save that. And for now, we're going to be done with our guard. Next, we need to go ahead and create our behavior tree. So I'm going to right click, go to the artificial intelligence submenu and grab behavior tree. And I'm going to call this BT underscore guard for behavior tree underscore guard. And then I'm going to open the AIC guard controller. In the event graph for this controller, I'm just going to right click and do on possess, event on possess. And when we start possessing this character, so when the AI controller takes possession of the character, all we need to do is run the behavior tree. So I can just do run behavior tree. It's going to ask us to specify the behavior tree asset. And fortunately, we only have one here, so that's just going to be BT guard. I can go ahead and save that. And just to prove that we are actually starting this behavior tree, I'm going to print running behavior tree after we've started the behavior tree execution. We don't need event tick or begin play, so we can get rid of those. I'm going to go ahead and save that. And in our viewport, or our level, I can just hit play in editor. And as soon as we begin play, we get that running behavior tree message. All right. At this point, I think we're ready to go ahead and open the behavior tree and get our blackboard set up. So notice up here that the blackboard button in the top right is grayed out. We can't access it. But there is the option to create a new blackboard here. There's also in the details panel a blackboard asset selection. Now, either way, we can just select new blackboard here, and that's going to open a save asset dialog. Or we can go to our content drawer, right click, artificial intelligence, and select blackboard here. I'm going to name this BB underscore guard, the BB being for blackboard, of course. And I'll go ahead and save that. And in our behavior tree, under the details panel, I'll go ahead and select BB guard. Now notice that the blackboard now has the cell factor key showing up down here, and this button is no longer grayed out for us. So if we select the blackboard button, that's going to take us to our blackboard view. And we can see that there is on the left, the blackboard itself, and then blackboard details on the right. We'll come back and talk about this when we actually add a new key to it. But for now, this forms the foundation for setting up our character and being able to have the NPC walk around within the world. let's go ahead and take a quick look at some definitions before we get too far into actually implementing stuff in the engine. So here in the behavior tree, we have to talk about the nodes that make up a behavior tree. And there's three very common ones called composite nodes, right? Composite nodes are the foundation of building behavior in behavior trees. And there's three of them that we really need to be aware of. So we're going to talk about the selector, the sequence, and the simple parallel nodes. The selector node is used to determine which child task to execute, right? So a selector node will execute all of its children from top to bottom and left to right until one of them succeeds. Once a task succeeds, it doesn't process anymore. We'll look at an example of that here here shortly. The sequence node, on the other hand, will execute all of its child tasks until one of them fails. So it's the exact opposite of the selector. Selector will work until one succeeds. The sequence will work until a task fails. The third one that we're going to talk about is the simple parallel. Now, we're not actually going to use this today, but it is useful to at least know about. So the simple parallel is used to execute one specific task while executing another decision tree. This is useful in the case of executing a subtask within a larger task. So for example, we're going to be building a guard that patrols today. And the guard is going to walk back and forth between different points. We're going to be using random point selection, but you could also have like a predetermined path that they walk about. But it would be useful to also be able to have that guard look left and right as he's patrolling, right? Checking his periphery to make sure that he's not missing anything. So that would be a good use of the simple parallel, where you can have a look left and right task while the larger task of actually doing the patrolling is happening at the same time. So that's a good use case for the simple parallel. It's just great for being able to run a subtask within a larger task. So looking more in depth at the selector specifically, the selector, like I said, will execute its child nodes until it succeeds on one of them. So looking at the picture here in the slideshow, we have the AI root selector at the top, and then it has two sequences as child elements beneath it. Now, we'll be building this out over the course of 2 videos, so don't worry too much about the Blackboard base condition and the child tasks underneath that. But what's going to happen is the AI root is going to execute the node, and it's going to execute the first child on the left side. So that's going to be this investigate sequence. Now, if this succeeds, then we're done. We're not going to bother doing the patrol sequence on the right-hand side. However, if the investigate sequence fails, as in we can't execute it, there's nothing to investigate, or we didn't find anything, then we'll go ahead and go to the patrol sequence. The patrol sequence is going to then execute its own children, left or right, and as long as they keep succeeding, then the overall selector will succeed as well. Looking more closely at the sequence node, and we've got our patrol sequence specifically here. The patrol sequence is going to execute each of its children from left to right, and it's going to stop when one of them fails. So our first task is going to be finding a new destination. Assuming that that works, we're then going to move to that destination, and then we're going to wait 5 seconds. And if all 3 of these tasks succeed, then the overall patrol sequence also succeeds. However, if any of those tasks fail for any reason, say we couldn't actually reach the target location, maybe there was a blockage or a bridge, the terrain just doesn't let you get there anymore, right? If the move to task fails, then the whole sequence fails as a result, regardless of how many successful children occurred before the task that failed. So going back to Unreal Engine, we can go ahead and start implementing that the patrol logic that we've got. So I'm going to start by going to our behavior tree, and we always have to use a composite node from the root entry. So I'm going to just go ahead and do sequence here. Since we are only doing the patrolling logic today, I'm not too worried about going directly into a sequence. typically we like to use a selector first, just in case we have multiple different behaviors we need, but a sequence is also perfectly fine. The core thing to note is that the root entry point of our behavior tree can only go to a composite node. We couldn't do a task, right? Even the context menu only provides selector, sequence, and simple parallel nodes to us. So I'm going to rename this node, the sequence node, to patrol. And in order for us to do patrolling, there's three things that need to happen. We need to know where we need to go. We need to move to that position, and then we need to, observe or wait around there. This is a very common first sample, and I'm also starting with it because it kind of forms the foundation of expanding our NPC later in the future. So I'm going to start. We need to create a new task, and that task is going to be determine where we want to move to. So I'm going to go ahead and up here on the top left, I'm going to select a new task, and that's going to create this save asset as dialog for us. And I'm going to call this BTT, determine patrol location. And that's going to open another blueprint editor for us. So all I want to do, we're going to use a random path selection. So I just want to take my actor's current location and grab another spot within, 500 units of where we currently are. So I'm going to start by, under the override section in the functions, I'm going to do receive execute AI. And that's going to give us an event with the controller, which is going to be our AIC guard controller, although it's going to defer to just AI controller, as well as a pawn that we are controlling. So this would be our BP guard. But using that pawn, since we want to grab a random location around us, I'm just going to take the control pawn, do get actor location, and then we also need to just find a random point within a radius. Find random, get random? Yeah, get random location in navigable radius, right? So we're going to take the actor location and pass that to the origin, because that's where we need to start our search from. And then for the radius, I'm just going to go ahead and make this 5,000. So we can kind of pick anything in a very large area to go and patrol around. We could make this smaller to limit how far he can move at any given action. And we could realistically expand this so that, he has to move a minimum distance before it would work. But for today's purposes, we can keep this pretty simple and just allow selecting a random point within 5,000 units. So I'm going to go ahead and grab that execution pin and connect it. And then once we have our random location, we need to be able to inform the behavior tree where it needs to move to. So this is where our blackboard actually comes into play. So I'm going to go ahead and switch over to looking at the blackboard really quick. And we're going to start by adding a new key. And this key is going to be a vector. And I'm going to call this target location. Now the naming is very important because we do reference entries in a blackboard using its name in some cases, not all cases. So it's very important to, when you use this name, to be very exact with what you're calling it. Spaces are okay, but I prefer to just use Pascal case, which is where you capitalize the first letter of each word and don't include spaces between things. So going back to our behavior tree task, I'm going to create a variable, and I'm going to call this target location key. And I'm going to change the type of this variable to be Blackboard key selector. So this is going to be a handy way for us to have a safe handle to our Blackboard and to the actual key that we want to update. The only thing we need to do to make this work, though, is to check instance editable on this variable, right? So if you click it over here in the details panel, it's just a checkbox next to instance editable. But on the left side, you can see that there is this eyeball here under or next to the variable. If I close that, the instance editable goes away. But if the eye is open, then it means it is instance editable. It makes it a public variable that we can modify elsewhere. So I want to go ahead and get that target location key, and we will set Blackboard value as vector, right? Because we want to take this new location that we just got, this random location, and we want to tell our behavior tree that this is where we want to move to. So once we've connected those, the last thing we need to do is finish this task. Let our sequence know that we did this correctly. So I'm going to right click and just do finish execute. And it wants to know whether or not we succeeded. Now, because we're just finding a random location around us, it should be pretty straightforward to succeed in most cases. But if it's not possible for us to find a location, this get random location and navigable radius will return false to us. So we can actually use this variable to determine whether or not the overall task succeeded. So I'm just going to go ahead and connect that directly to the success pin of finish execute. Then I'm going to go ahead and compile that and save it. And then going back to our behavior tree, the first thing we want to do for our patrol is actually find where we want to move to. So I'm going to drag off of this sequence, and you can see under our tasks here that there is BTT determined patrol location. So I'm going to go ahead and save that. Now, notice here that we've got this target location key specifier. This is the variable that we created in our task. So I'm going to go ahead and set that because we actually want to update the target location of our Blackboard. And that's the purpose of this target location key Blackboard selector, is it ensures that we are passing the right key to update without having to do a bit more obtrusive kind of behaviors, because you could have to do get Blackboard and then set value as vector, and then we'd have to pass the key name, right? This gets a little bit cumbersome, and it's just much easier to have a Blackboard key selector that we provide from the behavior tree to inform all that decision. So we don't actually need to do the get Blackboard and set value as if we provide the Blackboard key selector variable, which is a super handy, safe way to ensure that we're updating the right thing. So that goes ahead and once we've determined our location, we can leverage the move to task to actually move our pawn there. Now there's two important things to check here. And when we type in move under our tasks, there's move directly toward and move to. The move directly toward is going to ignore the navigation mesh or navigation bounds volume, and it's just going to make our character move directly to that point regardless of how it needs to get there, right? This does as a straight line between point A and B. Move to, on the other hand, will navigate using the nav mesh bounds volume, which is what we do want in case we need to avoid an obstacle or jump over something to that effect. So we're going to go ahead and use move to. And this also has a Blackboard key that we want to check. So I'm going to go ahead and change that to target location because that's where we need to move to. And then the last thing I want to do is just wait. We'll wait 5 seconds. Actually, we'll go ahead and make that 3 seconds. Just to kind of get a new position kind of quicker. You can specify random deviation. So if you wanted to vary the amount of time you spend in one location, you can add some random deviation to this wait time, and that'll do plus or minus X amount of seconds. So this is the foundation of our patrol mechanism. So I'm going to go ahead and save that. And up to this point, it's not going to work quite yet because we haven't actually added a nav mesh bounds volume to our map. So our AI doesn't actually know where it can navigate to. So in order to fix that, I'm going to go up here to the place actors button, and I'm going to do volumes. And then the very first one on the list is nav mesh bounds volume. I'm going to go ahead and click on that, and that's going to add that to my world hierarchy, world outliner. But notice that it's just a kind of a volume, and it doesn't provide us a lot of useful information yet. So I'm going to go ahead and click P, and that's going to turn on the nav mesh navigation debugging view. And we're still not getting anything quite useful. But if I take this nav mesh volume and I drag it down so that it's intersecting with the floor, you can see this green square appear. Now this green square represents all of the valid surface area that our AI can navigate around. So I want this to kind of cover our level as a whole. So I'm just going to scale this a little bit in this direction. Now, there are performance implications for having such a large mesh volume, and it may be more appropriate to use multiple different nav mesh volumes, but for our project here, we're okay just to have the one. So I've increased the size of the nav mesh bounds volume, and you can see anywhere that there's green is where our player can actually get to. Our guard can actually get to. So if we go ahead and hit play here, then you can see him moving about, right? He's picked a random spot and he's just on a mission to get there. Unfortunately, he's just gliding across the ground, which isn't really ideal. And this is super easy for us to fix. So we'll go ahead and do that. We're going to go to the BP guard. It might be the controller. It's BP guard, I'm pretty sure. And we're going to just search for accelerate. Yes, so under our BP guard character, we're going to search for accelerate in our details panel, and we want to check use acceleration for paths. And the reason why we need to do this is because the animation blueprint for Manny is driven by acceleration, right? That's how it knows that it's moving with the component. We could go look at that and dig into it. But the short answer is that it gets the movement component's velocity, and that determines the ground speed, which is what's then used to drive the animations within the animation blueprint. So if we weren't using acceleration for paths, then it has no concept of how fast it's moving when it's actually moving. So with that selected, now we can see that our Manny actually runs between points A and B. It looks like he's got himself a long route. This is what we get for using 5,000 for the radius. But that is our patrolling character, guard, for this first video. So, to recap, in this lesson, we built our behavior trees and blackboards for the first time, so we should have an understanding of how a behavior tree is used to drive behavior in a character or pawn, as well as how a blackboard is used to store information that the behavior tree can derive. We've also created a custom task to determine our patrol location for our guard, which is used in the behavior tree to determine where to move to. And then we built an actor that actually patrols a random area. We used a nav mesh volume in order to determine the area that is considered valid for our guard to move. In the next lesson, we're going to expand on behavior trees and add an investigation sequence. We'll be using decorators to ensure that we only enter the investigate sequence when appropriate. And we'll be using the AI perception system to respond to stimuli. So we'll generate noise events using a trap actor, and then the guard will hear the noise and it'll go and investigate the noise events. So I look forward to seeing you guys in that video when I release it. If you have any questions or comments, please drop them below, and I look forward to seeing you guys in the next video.